So for the ligand proposal, right, what you guys are going to be expected to do is kind of come up with a synthetic scheme. So, in 350, 360, you've probably went through, doing retrosynthesis where you have a final product that you want to do, and you have to figure out, well, how am I actually going to synthesize this, using what I know. And so instead of, it being the way that it is in 350, 360, where off the top of your head, you have to come up with the different reactions because there are so many different types of ways of adding atoms together and making new molecules. It's a lot easier to just use a database, right? And so the database that I personally like to use is Reaxys. I know some people like to use SciFinder to kind of come up with reaction schemes, but for organic molecules, I'm a huge fan of Reaxys, so I'm just going to go through how to use Reaxys for this purpose. So, when you go to the Reaxys link, right, you have to, I think you have to be on Brown's network. I would be just in case. I know you also have to sign in, and so if you haven't signed in since 360 or 350, you probably have to go through the whole password recovery process. But once you get there, right, you should be looking at this part right here. So if we go, what we can do is we can draw a molecule, right? And so hypothetically, maybe in my mind, I was like, oh, okay, I want to have a molecule that has, as my ligand, right? I want to have something that is, tridentate and has, a nitrogen and then two oxygens on it, right? So, this will hopefully give me the geometry that I'm looking for, right? So we can just build our molecule the way that we want, right? So I'm building, this guy right here. And then one thing, I might want to be like, oh, I actually want to have a little bit of steric bulk around these oxygens, right? And so I'll just put, some isopropyl groups or something like that right there, right? Because I'm like, okay, right, this roughly meets the requirements that I think makes the most sense, right? And so then in this case, right, you have all of this set up. Initially, right, you might want to simply do as drawn and see, does this compound actually exist, right? But also when you submit it, it'll also probably tell you maybe some similarities as well, but we'll see, right? And then we can also just keep these guys here all clicked because, it might still give us information in terms of figuring out the synthesis. So we have it drawn, we go to transfer to query, we see it right here, now we click on find. So first things first, right? So as drawn, that substance isn't known, but one thing that happens, right, is that if you have something that's kind of close, right, you may get some hits there, right? So in this case, I got 153, and so I'm looking at these results, and so I can kind of like scroll through and kind of get an idea, and look at the structures, right, and like, do they match what I want? So none of these really right here are directly matching from what I'm seeing as having, a kind of a pyridine with two, aryl alcohols nearby to make a good tridentate ligand in this case, right? They all look like some, all over the place molecules, right? And we're kind of getting into the territory where we don't have stuff. So, this isn't necessarily, a bad thing, right? So that just simply tells us that as it's drawn right now, right, that might not be the right thing to do. And so, one thing we can do is think about, okay, well, let's scale back a little bit and see if we can find a kind of related molecules in that case, right? Because then we can come up with, maybe a synthetic scheme to make a whole brand new molecule, right? But using synthetic techniques and pathways that have already been explored. So what I'm going to do now is I'm just simply going to remove those isopropyl groups, right? Because I'm like, okay, well, with the isopropyl groups there, those, that hasn't been found, but let's just look at it just like this completely naked, aryl rings right here and see if this happens, right? So I'm going to transfer this now, and now I'm going to search for this guy. And so we look here for, now I get 7, right? So I get 7 hits directly of that. So that tells us, right, that at least this molecule is known, right? And so we can see it right here. And so there's a few different examples, right? We already see some that have, either radicals or they're, the protonated versions of it, right? Or even deprotonated, right? So there's even like an iron 3 complex and stuff like that that's known. There's a zinc complex. And so, for this guy right here, right? So that's already known in terms of both serving as a ligand, but also as a molecule, right? So, if we find one that we have, what we can do is look over here to the right. We can see there's 3 different options, right? There's preparations, reactions, and documents. So what reactions is that where, those are then, examples where this is then used as a reagent. What we want to do is click on preparations, right? Because this then tells us how we can prepare that molecule. So if we click on this, there's 5 different preparations, roughly that are given. And so we have, this example right here, first off, where we're going from, forming the alcohols from the esters, sorry, not esters, from the ethers. Right, then there's this example right here where it doesn't really give us much information necessarily, but we can kind of look through this multi-step reaction right here and see that, there's a few things that happen right here, again, all of these things. So in my mind, I'm going to probably go with this one right here, right? So just looking at this, just going from the ether to the alcohols, right? There's a few different examples that we have. And so, basically, it looks like you just simply use pyridine hydrochloride to do the deprotonation in this case, right? Or at least some type of pyridine compound. So in all these cases, they're pretty similar. And so, what you would want to do then is essentially, go into finding these papers, right? So, ChemCom, very common journal. So, you go through and you should be able to find it, right? And we can then look at the article. So if you're on the campus Wi-Fi, this shouldn't be a problem, right? And so we can go through, right, and we can then find what the synthesis is. And a nice thing too, right, looking at it right here, it looks like you can kind of already see what the entire synthetic scheme is, right? So even though right here we were only looking at it going from this step to this step within this paper, right, we're already going from this starting off ether bromo aryl compound, right? And so this is going to be a Grignard reaction, and if we look right here at the different conditions, right, THF step 2 nickel chloride together with dibromopyridine, right, 25 degrees Celsius, so room temperature, 12 hours, right? So those aren't bad conditions, right? And then you get this guy, and then you can, go through the process of, removing the ethers and forming the alcohols, right? And it looks like you just use pyridine, hydrochloride at 200 degrees Celsius for 3 hours. So that's not bad, right? So it just even, directly right here for this example, right, we were able to find it all within a single paper, right? And then you have, all the details and stuff that you can get. And so, one thing to keep in mind is that, for some of these papers, especially communications, the actual, steps aren't necessarily going to be in the direct paper, right? You'll probably have to look at the supporting information. So let me just see where it is in this case for ChemCom. I guess they don't have it directly right here, but then again, right, if we read through the paper, it'll probably actually give us what the original paper was that went through this process, right? So, reading through our way through it, blah, blah, blah. So it looks like it was, citation 15, right? So this one right here, JChem, Sock, Dalton, Trans, right? So that might be one of the ones that are somewhere in here, but maybe not. So, but what we can do is, right, we could then go here, right, and we can click on that, try and find it through Brown's library. Either way, right? I mean, this is going to take a while, but I'm not going to hold up your guys' timer. But you want to make sure that you're kind of like, double checking that the citations that you have actually give the conditions and the actual reactions in those cases. But now let's say hypothetically, right, you want to go from you're only being given this step right here. And so you want to find out how to make then the reactants that you're looking at right here. Right, so after you've copied all this information down, there's all these different options down here. So if you click the one that's all the way to the right where it says create synthesis plan, you can click on that. You can click on find preparations. So if you click on that, right, now this is giving you a bunch of different reactions that then end up forming, the products that you want. And so, what you can do is you can go from, with 2 bromo andesol with magnesium THF, right, to take that, right, and then you use the 2,6-dipromopyridine, right, and then all of this, right. So this is going back to the ChemCom paper right there as an example. There's other examples where you can do a cross-coupling reaction, right, and so this cross-coupling reaction, where you're doing a Suzuki Miura coupling, right, might be a good step, right. So you're like, okay, right, I'm looking into it. the dibromopyridine, right? So that's commercially available. I think this might even be commercially available, but let's say hypothetically, right, you didn't want to, you wanted to prepare it fresh, right? You didn't want to just simply go on the market and buy it, but you can, again, you can check that to see if it's on Sigma or Strem or Thermo Fisher or whatever. Again, right, if you have another step and you want to create this, you go here again, right? You can do create synthesis plan. Now, one thing you can do too, right, instead of clicking on find preparations, you can just go to create synthesis plans. Right, and that starts building up everything that you have here, right? And so, this is choosing one for us right here, and that necessarily might not be the ones that we actually want to do. We might want to find a different one, right? So, if we go back, so let me just click back right here. Right, so we go right here, and we're like, okay, find preparations, and so now, we're looking to see if we can find a way to prepare, our boron compound for the cross coupling, right? And so we can see right here, okay, right, we're going to use the trimethyl borate, and then we're going to use 2-bromoanisole, right? And so both of these I know for sure are commercially available, right? And you would have to use N-butyllithium, but that would be essentially the way, right? You would get to a point where you have something that's commercially available, where it isn't prohibitively expensive, and then you're like, okay, right, like these are the conditions, and you build it all out. And so again, right, if you wanted to, if we're gonna move our way back, you can do the synthesis planner part. So if we take this right here, create synthesis plan, right? So if we create the synthesis plan for this right here, again, it's choosing, I've never used the synthesis planner, so you can just disregard what I'm doing right now. But either way, right? So that's, the way that you would go about, essentially working your way back from a starting compound, right? And then working your way forward. Now, going back to what, I was originally talking about when I was trying to make it, right? So I was trying to make the isopropyl group. So if we go back to this preparation here and we go back to our initial points, right? The initial point that we would then have to essentially do some kind of modification would be on this group right here, right? So, if we're going to do the cross coupling one and we're going to be synthesizing that from the beginning, what we would need to do is then synthesize it where we have an isopropyl group here that's, alpha to the ether group off of this right here. And so, we can look into how you would synthesize that, right? So if we go back and go right here, right, and we can click on copy structure to query, right? So if we do that, copy to query, right, this is now in here. We can modify this. We can click on here, go in, right? Now I'm just going to add the isopropyl groups right there, transfer this back. And now we can try and see if we can find this, right? And so now I have a result here, right? And so I have this, right? And I have the reactions. And so I know, this is how I can synthesize it. Sorry, not the reactions, right? It's the, I would want preparations, but there aren't any here, right? But it has been used before, right? And so we could look here in this example and see how they prepared it, right? Because it's not being given directly. So if we click here on find it, I know this videos end up being a bit longer than I intended it to be at this point. And I know I'm kind of just rambling, going through stuff, but this is the general gist of searching through the literature and finding stuff, right? So if we're going through and looking, right? So here, it's giving us the details of, these different parts. So, this R group right here, right? What we're looking at is at the, which one is it? Yeah, so this R group right here, right? So we're looking at 2-propyl, 6-orthomethyl, right? So that's, entry 16 right here. And if we read through and go here to the bottom, right? Synthesis, palladium catalyst, standard reaction procedure. It doesn't give us the exact details in that regard for this paper again. I don't think that there's a thing here, but essentially, right, for a lot of those reactions to make the the aryl boronic acids in these cases, right, it's extremely similar to what the reaction was that we had looked up earlier. Let me see if I can, I can't click my way back, but essentially, going like that, right? So again, using some of that chemical intuition that you've been developing over the last, 2 years of taking chemistry classes, and thinking about, okay, right, well, what functional groups are kind of similar, right? So what can we get away with if we're switching out, something that's, originally a hydrogen and we're putting another group right there, right? So in my case, I wanted to put an isopropyl group right there, right? And then seeing like, okay, well, how does that change it? Will it change the yield? Probably. It might change the reaction conditions that actually need to happen, but considering that we didn't actually see in the literature an example of that specific molecule we're looking at, right, that would be, an interesting project no matter what, right, to synthesize that and kind of explore that on its own. But the idea really is for you guys to kind of come up with, some interesting ligand platforms, that can be synthesized, hopefully, by a group next year in Chem 500 when we're hopefully able to be in person again, fingers crossed. So that way, right, we can do some interesting stuff there. In that regard, right, and kind of explore new things. And so if it's, a new ligand that, in our minds can exist, but nobody has tried to actually synthesize or anything like that, right, that's always an interesting and good thing to do. So, so I mean, that's, essentially how you could use Reaxys to kind of use some of those, retrosynthetic skills to kind of go through and figure out, a pathway to prepare, a ligand that you might be proposing or thinking of, being of interest in these cases.